Hey guys, Jim here from Budget RC, and today we're trying out the new high steer aluminum knuckles from Redcat for the Gen 7 truck. We're going to see how it compares to the steering upgrades we did previously on this, so stick around.
Okay guys, so what you're looking at right here is the setup that I'm currently running on the truck. If you've seen my other video that took you through the step-by-step upgrades on improving your steering, this should look familiar. If not, I'll link it below. Make sure you watch that video because that'll also take you through the step-by-step removal process, which I'm not going to go through here. But anyway, just as a recap, you can see here that in addition to the new servo and the aluminum arm, we've also got this that's longer than stock because of this bent arm here. This section here you can see we raised up to give us clearance behind the pumpkin. So the new system's a little bit different, and we're actually going to have to go back to a lot of the original hardware to use it. But before we do that, what I want to do is measure the steering angle with the truck like it is so that we can do a comparison of the steering angles before and after. So let's go ahead and get that measured. Okay guys, so what we're going to do, I've got a piece of paper under here, and I'm going to line up this ruler with the tires to the best of my ability. Draw our line. Now I'm going to go full lock. Draw my line again. Now, clearly this is not an exact science, but it should give us a fairly good indicator of what exactly we're seeing for a difference before and after. Okay, so this is how I'm measuring my angles. I've got this along the straight path, this one along the turned path, and I'll do this for all four and see what we get. Okay, so now we've got our angles marked out, and if you take a look, what we've got is that when we go full left, the outside wheel turns to about a 31-degree angle, and the inside wheel turns to about a 27. When we go full right, you have a 33-degree angle on the outside wheel and a 29-degree angle on the inside wheel. So our outside turn angle, we can see that we've got 31 degrees and 33. If we take an average, that leaves us with 32 degrees. The inside turn radius, we have 29 and 27. So again, if we take an average, we have 28. So what we're seeing is a difference of 4 degrees. Our outside turn radius is turning 4 degrees sharper than the inside, which is pretty much the opposite of what you want. Because the inside is turning a tighter radius, you want more angle on the inside. So now we'll go ahead and get the new parts put on. We'll go through these measurements again and we'll see what we get. I've got one side apart, and now what I want to do is show you some of the differences in these designs. On the left I have the original plastic one, and on the right obviously is the new aluminum one. Now if I hold them side to side, one thing you can clearly see is that the steering arm is much higher on the new piece. The original piece, the steering arm is centered, and that's more for economy than it is for performance. That allows this one to be used on either side, so you have half as many pieces to design. This piece here now is of course unique to each side, but there are some definite advantages to having that up higher. What it does is it moves that steering arm out of the way of all the junk on the trails, and more importantly, moves it up above the center of the pumpkin so you don't have to play games with offsetting or bending the rod like we've been doing to get better steering out of this. Now secondly, so with these holes lined up, what you have is this arm here, you can see, is further away from the pivot point than this one. And it also looks like it's a little bit further back. And that's going to change the steering geometry and how the two sides steer in comparison to each other. And that's how the Ackerman changes. First of all is that these collars right here, you need to make sure you pull these out of your plastic arms and transfer them into these arms. The new ones don't come with it. They slide right in there. Secondly, when you're installing these bearings, this is a tightly machined hole, and the bearings fit very snugly, so you have to make sure that they're lined up perfectly. This larger one I was able to push in by hand, but the smaller one out here was snug enough that I had to put this into a bench vise to make sure everything was perfectly square, Once I put it into the bench vise, it slid right in. But by hand, I couldn't get it to go. So just take your time and be careful and don't force it. So now we can take a look at the new parts. First of all, we've got the new drag link, which is longer than the old drag link, and it's angled outward so that it's not anywhere near that differential. Additionally, because of the high steer arms, the position of the drag link is up a little higher, which also helps keep it away from the highest part of the pumpkin. The kit also comes with this longer link that goes from the servo arm over to the knuckle. Now if we turn the wheels and take a look, we can look right at these high link knuckles. Rather than this arm being in the middle like it was on the old one, it's up higher, which, as I mentioned, now helps get this tie rod away from the middle of the pumpkin. Now, like you saw in the comparison too, the position of this is also different. It's closer to the tire, which is why this link needs to be longer, and it's also closer to the pivot point as well, and that's what changes the steering angle. And again, we can look on this side too, and here you get a good view of just how much higher things really are. Now, we are pretty close to the tire up here. It's not quite touching, but you know what? It's awful close. So any tire flex could potentially cause this to rub on the tire, and if you have tires that are wider than stock, that could be an issue as well. So it may not be a bad idea to get some thicker hexes, which will push your tires out more. And that will also allow them to get a little bit further away from the springs and the lower links. So that may be a worthwhile investment. Okay, so now we've got all the new parts in, and I've just turned the vehicle on, centered the steering, and I have my endpoint set so that it won't overextend to the point where I'm getting into causing problems with the CV axles. But because I'm taking these measurements with the vehicle turned off, it's entirely likely that I may exceed that. What I'm really looking for here is, again, the difference in the angle from the inner to the outer, and not so much the raw number. So just like last time, we're going to start with our baseline angle. We'll do this on both sides, and I'll kick the camera for good luck. Okay, so we've measured our angles, and our outside angle on this side I measured 39 degrees, on the other side I measured 36. Like I said, it's not an exact science, but if we take an average we get 37 and a half. Hopefully that's close. So you can see there's certainly a lot more angle, but again, because we were already pretty much at the limits of what the CV axles could handle with the old steering, I don't think this extra angle would really translate into more steering on the trails. If we look at our inside angle, I measured 31 and 34, and again we got an average of 32 and a half. So this comes up with a delta of 5, which, based on my pretty poor measurements, it seems to indicate that the Ackerman got worse with these, not better. You know, maybe it's within the margin of error, but I certainly don't see where the Ackerman got a whole lot better. But we'll be taking this out on the trails in a couple of days, and we'll see if we can notice a difference in the real world.
So now we've got the new knuckles in. You can see that we checked the angles, compared it to what we had before, and I also took this out for a little bit of a drive, and now I'm here to give you my final thoughts. You were able to see from my measurements that the Ackerman angle didn't seem to change very much. My first thought was, geez, this is even worse than it was. But the more I thought about it, I don't really think it's any worse, even though I don't really think it's a lot better either, and here's why. Right now, the outer wheel is the one that has the most steering angle. The inner wheel has less angle. And I thought, well, geez, that's exactly the opposite of what you want. And to an extent, that's true. But with the geometry of this truck, where the lower links are, it's your inner wheel that's hitting the links and your shock, which, other than the CV axle issue, is what's limiting you. So by having more steering on the outer wheel, even though it's technically a worse Ackerman, you're already limited with what this inner wheel can do. So if you can get a little bit more steering on the outer wheel, it can still help you turn a little bit tighter. Now, how much tighter, I'm not really sure. I didn't have a ton of time with it on the trails, but so far, I don't really see much of a difference. Overall, I think compared to the stock steering, these provide a tremendous upgrade. It's a simple installation. You just replace a couple of parts, and it helps drastically with the steering compared to stock. But compared to the steering upgrades we've already made, most of which cost basically nothing, I didn't see any benefit. The steering doesn't really go any further in the sense that you're still limited by what the CV axles can do. This set of high steer knuckles is capable of turning a lot farther than even the upgrades I did previously. But because you're limited by the maximum angle of the CV axles, you can't take advantage of any of that extra steering. You're still limited. Now, if Redcat has plans to come out with a set of CV axles that provides more steering, then I think these will be a huge benefit. In the same sense, if you were looking to upgrade to the aluminum knuckles anyway, then by all means going with the high steer knuckles is still a better solution than the standard ones. It's about the same cost, and it's still going to give you a lot more steering once you have the opportunity to take advantage of it. If we have this here and we start to turn, you can see it's nice and smooth. And if I go all the way to the ends, you can start seeing it get a little bit notchy. Now with this shut off, I can turn it a lot further mechanically than I was able to turn it with the remote. But because you can see those CV axles starting to get notchy, if you extend your steer beyond that limitation, you're going to start breaking parts. You'll either break your CV axles or you'll start breaking your C-hubs. So it's very important to make sure that you keep that dialed back. And when you do that, it brings you back to a point that I don't think is a heck of a lot better than the steering mods we'd already used. So anyway, guys, that's my thought. Are they worth the money? If you're steering right now with stock, you don't want to go through the upgrades that I had in my previous video, then yes, they're worth the money. If you were looking for aluminum upgrades anyway, yes, they're worth the money. If Redcat or somebody else comes out with a set of CV axles that allows more steering, yes, they're worth the money. But until some of those situations are met, you can really get the same amount of steering with the upgrades I've already gone through. So in that sense, maybe they're not. That's really up to you. Anyway, guys, I hope this was helpful. If you thought it was helpful, make sure you subscribe so that you can get the future updates that we continue to put out. Until then, thanks very much.